Welcome again. This lecture is in continuation with the previous lecture. So we were discussing about the conditions required for the measurement or for the measuring instrument. So first was it should be descriptive. It should be descriptive. So by descriptive we mean there should be a well defined relationship between object of measurement and the measured result. So it's like this, whenever we are measuring the so whenever we are measuring the body temperature with the help of thermometer, so we know that the bulb of the thermometer, if we are putting that bulb in some higher temperature, then there is an expansion of the mercury inside the capillary. So there is expansion of the mercury inside the capillary as a result of temperature change. So this is a definitive physical relationship between the temperature and the bulb of the thermometer. Okay, so there should be a well defined relationship between object of measurement and measured result. So, and second thing was it should be selective. Definitely it should be selective. Why? It should filter out all the noises. It means all the other parameters should be filtered out. So it should measure the quantity or the variable for which it is made. So the instrument should measure the so if we are using a thermometer, then definitely if we are putting that thermometer inside our mouth, then there are different things, the pH value of my mouth and the saliva in my mouth, and but there is a temperature. So it should react to the temperature. It means it should filter out all those other parameters. It should not react all those or it should not give any output corresponding to all those other parameters. It should give the output corresponding to the variable for which it is designed. Just like the wind, we are using some kind of anemometer for the wind speed measurement, then it should not get affected by the pressure, temperature and all the other various factors outside in the world. So it should not get affected by all those other parameters, and although other parameters are like noise to it. So as we have already discussed in our electronic instrumentation, in our analog electronics, so our devices should be resistive to the noise resistive. So it should filter out all the noise. So this condition is also applied to the instrument. So this is a condition that an instrument or a measurement should satisfy. Third thing is the objective. So it should be user independent, so it can be used by anyone. So and it should not be a user specific thing. Okay, so it can be used by anyone, or either by specialist or by a normal man. Okay, so it can be used. So these are the three conditions that the measurement should satisfy. I hope it is clear with the help of some examples. Okay, now let us move to the next slide. The purpose of measurement. Why do we measure? So measurement is an essential activity in every branch of science and technology. This we have already discussed. The purpose of measurement. The fundamental purpose of measurement is in industrial manufacturing and processing is to obtain a numerical value corresponding to a variable being measured, so that we can determine the quality of a product or the efficiency of production. So to improve the quality of the product in the manufacturing, the measurement is very necessary. Even the precise and accurate measurement is very necessary. So this you can understand with the help of this example. Let let us suppose we are going to buy some resistor. So if we are going to buy some resistor and we want a resistor having a very low tolerance, like 2%, 1% tolerance, then it should be very expensive. Then definitely it will be very expensive. And you have already seen that then if we are going to buy anything which is high, which is very accurate, then it is expensive. Obviously it is expensive, because if we are increasing accuracy of something, then definitely we are investing something more in that device, more hardware, or if it is a software kind of thing, then we have optimized the software, then more effort is required. So that's why the price is high. So let us come back to our example. So we were discussing about the resistance or some capacitor or some inductor. If we are going to buy some inductor, capacitor, or some resistor having a very low tolerance, it means tolerance means accuracy is very high. Let us suppose if we are going to buy a resistor of 100 ohm having a tolerance of 2%, and there is one more resistor available in the market which is of 100 ohm and having a tolerance of 10%. So here you can understand the difference. So this resistor will have the value between minus 9, sorry, not minus, 98 to 102, because the accuracy, or you can see the tolerance, or the accuracy is plus minus 2%, and here the accuracy is plus minus 10%. So the value of that resistor could be in between plus 20 to plus 90 to 110. So that resistor, so this resistor cannot be used for a very accurate or a very for very precise measurement. If we want a very accurate measurement, then this resistor cannot be used. If we want to use some resistor for the purpose of some measurement in a circuit, then we need to understand the accuracy which is required. So this is a kind of trade-off. So whenever the higher accuracy is required, then we will buy some resistor having a very low tolerance. It means a very high accuracy. So this is how you can understand the price of this resistor will be very high. Not very much high, but definitely it will be very high as compared to this resistor. So this you can understand. Okay, this you can understand. So here you can see wait, here you can see a digital clinical thermometer and a analog clinical thermometer, and this is also a temperature measurement device. This is a thermocouple. So what is a thermocouple? It is a device that measures a temperature, and it works on the principle of Seebeck effect. So whenever we join two different metals and we put those two metal junctions at different temperatures, so this is a measuring junction and this is a reference junction. The temperature of this junction is known, and this is the temperature of this junction is unknown. So whenever we put this kind of arrangement, then there is an EMF is developed. So that EMF is proportional to the difference of this temperature. So if this temperature is our known temperature, and then we can find the temperature of this unknown junction with the help of this EMF generated. So for this a calibration process is required, and definitely we will define what is calibration, so as we will go forward in the course. Okay, so this is an example of control of water level in tank. So here you can see the manual control here. This is the manual control here. So this man is opening or closing this valve according to the water level. So this man is looking at the water level, and whenever there is a water level, so here you can see there is no valve. Here there is a valve. So whenever the water level is high, then it will open the valve, and there the flow out will be there. So this is the block diagram of this thing. So this is a valve. Okay, so this is a valve here, and this is the outlet, and here the flow in, and we can maintain the level by observation. So this is what we call manual control, manual measurement. So manually this guy is measuring the measuring the level, and it is opening or closing valve according to the level.